Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my channel. Today we would be discussing Kmapping and we would be discussing its canonical form and simplified form. So first of all, I would be shifting to my circuit. That would be my first for simulation part. That would be in canonical form as well as simplified form. Simplified form would be a little bit greater than canonical form because canonical form would be definitely created with one input and output and would be much certain with it. So first of all, I would be defining this canonical form, this simplified form of this circuit. Basically, we have taken an input, a circuit with 4 inputs A, B, C, and D, and that would be having 16 outputs, 16 in input type, and its output will be 1. So, first of all, let's start with the circuit. I've created a truth table here, and to explain how it is working, I've created a key mapping over here. In this key mapping, first of all, I would have created 0, 0, 0, 1, both sides 1, 1, and 1, 0. So first when 0, 0, it's A bar, B bar, C bar, and D bar. When 0, 0, and 0, 1, it's A bar, B bar from 0, 0, and C bar and D from 0, 1. Then when we cross here 0, 0, and 1, 1, it's A bar, B bar from 0, 0, and C and D from 1, 1. Then to take to this 0, 0 for this and 0, 1 for this. So it would be A bar, B bar, C, and D bar. So next with the second row we would be going to it would be 0, 1, 1, 0, 0. This would be A and B. So A is 0, but B is 1, high logic. So it would be A bar, B, C bar, and D. Then from here would be A bar, B as from here, and C bar and D. And then this would be A bar, B, C, D as both CT are 1, high logic. Then this would be A bar, B, C, and D bar. Then this would be A, B, C as both A, B are positive. This whole line would have A and B as positive. And first would be A, C bar, D bar, then C bar, D, then C bar, C, D as common, and then as well. And this would also be repeated in the fourth column. If we look at over here that a formation over here, and we consider it as there, and we define it, so we can define this input logic as 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 14, 12, 13, 15, 14, 8, 9, 11, and 10. And this would be the logic that numbers would be present over here in the key mapping. Now I've created a simplified form of this in this whose truth table have also been given. Then it's if we have taken not ignorant of 3 or not ignorant and have created a pattern of 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, and with 8 inputs of high logics and rest are low logics. So what would be the key mapping form? From this key mapping that is created over here, I would be creating 4 boxes like four input boxes or 4 input boxes. So I would be having a circuit value of by here if by the circuits over here. So if we take this 2 as input, so this would be for example when taking these 2 inputs, for example, so I would be getting as uh, in this both B is positive, so B positive, and then for this both C bar D, and this is present over here. So just like this, I would be creating the mapping and I would be adding it in this, and this equation would be formed. Then after that I would be moving on the canonical form, Over here, the canonical form of circuits, I have also created a simplified form. In this, in the canonical form, in this, I have taken that if at any case, if there is 1 1, either AB is 1 1 or CT is 1 1, it is created as high logic. So over here, the CD is positive, then over here, um, okay, so here we can see that ACT is also again positive. Then over here, when we look at here, then CT is also positive. Excuse. Then over here, AB is positive. Then over here, AB is positive. Then over here is AB positive. And then over here is AB is positive. So this canonic K mapping would be formed, and by using this K mapping, we would be having two equations that would be one this for circuit and one this for uh, uh, a rectangle. So this four rectangle would be giving us two equations of f is equals to ab plus cd without any negative sign. So this would be our truth table and key mapping, and then when implementing them on Proteus, I would be having over here this circuit. Sorry. So first of all, this is a working circuit. So I would be simply be taking the values from here from my stimulation, and I would be seeing that are they is simplifying amplifying are they the output uh, are they justifying it or not. So first of all, I would be going to, if b is only positive, then it should be 1. Okay, so b is so, okay, so I would be, yes, so this is b, this is c, this is d, and this is a. When I've created one, cb is positive, the output is positive. So this is also implementing as truth. Okay, now next form we would be going as yeah. Uh, okay, so now next part would be next we would be implementing as if B and D are positive. So we would simply go ahead, already on, so I will simply be owning this, and it is also present over here that this circuit is positive. So next we would be implementing as for 0 0 if C and D are positive only. So I would just this right, and then C and D are positive, and this would be a low logic. So this circuit, mainly all of the values, all of the inputs that are present over here would be implemented and would be giving the same output as it would be giving over here. So it would be it's justifying the circuit. Then I've also done this on Quartus to explain the circuit. I'll simply be going here from Quartus. Quartus and simplified form. I've already done it. Okay. Taking a little bit time, but it would be. So first of all, I would simply be showing you the circuit. So it's a simple code. It's not a big deal, not very lengthy or very complicated code. It's like a module I've implemented the same syntax of Quartus that is already of video of Verilog that is already present, and then I've taken in four inputs, one output, and then the same equation that I have got from the key mapping I have implemented here by using and, or, and not gates. Then when I've seen its RTL view, it is represented over here. That is the same RTL view that I have got from Proteus circuit. So let's see its waveform, and we would be implementing one of the logics that we have now, one of the inputs sets, and we would be justifying the truth table. So first of all, we were having taking as any, sorry, this is the correct taking any of them, which I prefer the 1 1. So this is 0 B and DR1 positive. So I would be simply going here positive the high logic of this and high logic of this as well. So I simply open yes and save, and this would be running. I hope so there wouldn't be any errors. I've already run this type of circuit already over here, so waveform should be produced. um, Okay, so this, and yes, that is giving us the positive result of 1, and this is proved. We can also do that, do any many of these waveforms over here, and can justify our circuit, and it would definitely be justified. So after the removing it, I would be going to the conical form of it. So this is a truth table. I would be going justified as that is just as simplified as our simplified part is proof. Now we are going to canonical form. Canonical form has a very input over here, a very good input over here, that we have used a circuit, and that would be a plus b. So we're simply going to the quarters that I formed this is a simple circuit, simplest part of it. I'll just go from here to, I've already run it, so I'll just go from locate node and just our view article node, and this would be a very simple circuit over here that is produced over here. Then I would be seeing the its implementation uh, for this in the waveform. I've already done the simulation, and I will simply be showing you that if any of the C or D is 1, either C and D is 1 or A and B is 1, so it would give a positive input. So over here, when I have done A and B is a positive input, sorry, here in positive input, it resulted in positive output. Now I would simply be changing it, and I'm sorry, it's a wrong one. I've done it over here, so I will simply go insert picture. I've saved it over here. Okay, so by mistake I have taken the same as one, so I was simply going to Quartus and changing this. I've taken the same input and I've done it. So I would simply be going into conical form, and I will be showing you the waveform of if C and D are positive. So over here, we have implemented the circuit, and here it is produced as uh, giving us the output of 1. As if C and D is positive, this is giving a 1 output. That would certainly be our circuit implementation. And if by here we have also done that if A and B are positive, it would also be giving us the input output, uh, the output as 1. So this circuit would also be implemented and would be proved. I've implemented the circuit of the waveform over here, and it will be now it is a correct output. Okay, so after this I would be showing you the Proteus implementation over here of the canonical form, and this is a simple canonical form circuit. In canonical form, the logic was if any of the C and D is one, either 1 1 logic, or A and B is 1 1 logic. So I would simply be going the C and D is 1 1 logic and it is proving it 1. So I would be simply it 0 0, and you can see it's 0, and simply I'll just yes, and that is proving as 1 1. So by this our circuit is already proven. So if I've already seen that 1 1 of C3 and 1 1 of D. Now if you want to check the reverse side, if any one is look, if any C and D is C is positive when D is negative, or B is positive when E is negative, then also this circuit will not be implementing as a positive high logic, and that is proved with our conical form. Thank you very much, and I hope you would be able to understand it. Jazakallah khair.